Let's talk more about the temperature and pressure effects of mixtures. We'll start with the example of looking at a solid dissolved in a liquid. The process of a solid dissolving in a liquid is called the process of solvation. The particles that make up the solid are surrounded by the molecular particles of the liquid. They're solvated. If the process occurs in water, if the liquid is water, we usually refer to this as hydration. And in general, although there are some exceptions, in general the process of hydration is endothermic. What that means is the process of the process of dissolving, the process of taking the solid and the liquid separately, the equilibrium process, because all processes are equilibrium processes. This process is endothermic, which means heat is added for this process to go. Again, there are some exceptions. There are some solvation processes that are exothermic, but by and large most of them are endothermic. According to Le Chatelier's principle, which says if you have a system at equilibrium and you stress it, it will shift to relieve the stress. If you raise the temperature, that is the same thing as adding heat to the solution, the process, the mixture. If you raise the temperature, the reaction shifts to the right, the equilibrium shifts to the right, which means you get more mixture, which means you increase the solubility. Again, there are exceptions to this, but in general, at higher temperatures, you have higher solubilities for solids in liquids, solids in solution. How much more? This is something that's usually determined experimentally and is represented in something called a solubility curve. A solubility curve is a graph of solubility versus temperature, and in general, although they're not typically straight lines, although we might see some that are straight lines, in general for all substances the solubility increases as you increase temperature, but we're going to see a wide variety of types of lines and different sloping lines for different substances. You probably have a bunch of these pictures in your textbook, and every once in a while you will see a substance whose solubility actually decreases as the temperature goes up, or even kind of stays flatlined. Again, this is something that's typically determined experimentally, but in general, if you had to guess, you would probably guess that the solubility increases as the temperature increases when you're talking about dissolving a solid in liquid. If we're looking at the solubility of a gas in liquid, what we find similar to solids and liquids is that we do see some gases that are more soluble in liquids as you change the temperature, as you increase it, some gases that are less soluble in liquids as you increase it. So this is something that needs to be determined experimentally. There are some that you might be familiar with, which direction it goes. For example, if you're looking at oxygen dissolved in water, oxygen dissolved in water is how fish breathe, essentially. Fish don't breathe water, they breathe the oxygen dissolved in water. And as you increase the temperature of the water, you actually decrease the solubility of the oxygen gas. In an aquarium or a lake or a stream or something, if the temperature gets too high of the water, less oxygen is going to be dissolved in it, and the fish may die if they don't get enough oxygen. But in general, essentially determining whether or not an increase in temperature will increase or decrease the solubility it goes both ways, so you're going to have to just determine that experimentally. All right, to wrap it up, let's focus on the pressure effects of solubility. When you're talking about a solid dissolved in a liquid, you essentially see no effect from pressure effects. If you change the pressure of the room or the container where you're dissolving a solid in a liquid, it essentially has no effect on how much will dissolve. But if you're talking about a gas dissolving in a liquid, it absolutely positively has an effect. And in general, if you increase the pressure of the gas above a liquid, you push on it more, you're going to increase the solubility. This is a nice linear relationship. It was studied by a guy named Henry, and so we call this effect Henry's law. The solubility of a gas in a liquid increases proportional to the pressure of the gas. The proportionality constant is called Henry's constant. There are tables of these values. You can just look them up. And so you could actually calculate this because it is a nice, neat relationship here. You can calculate how much gas would dissolve in a liquid at certain pressures if you know the Henry's law constant.